Welcome to multiplying and factoring your polynomials. 7.2. So let's get started by putting our name on this. Make sure that what's yours always stays yours. And what we're going to be doing today is essentially running the machine both forwards and backwards. So what does that mean? It means that if you're running forwards, you're going to be multiplying through and then putting terms in the right order. So we are going to have to work with the possibility of changing exponents and coefficients today. So we're going to be very careful with that. And to run the machine backwards, you are going to be dividing or factoring. And when you're factoring, you're looking to see what all of the terms have in common. Is there a coefficient that they are all divisible by? And do they all have a common variable that we can look at? So there will be changes of both coefficient and exponents today that I'm hoping you're going to become very smooth at working with pretty quickly. So let's start on problem number 1. We are told that we need to write this in standard form, remembering that in standard form has no parentheses and it has to be in order from the highest to lowest exponent. Let's check out problem number 1. So this is a skill that truthfully we should already have. It's just a quick review, and that's okay. So 7x times the quantity of x plus 4. So we're going to distribute all of the 7x to each term inside of the parentheses. So before we get started, what is the coefficient in front of this x? Yeah, it's a 1. Good. Because remember, if nothing is showing, there's a 1 there. Good. So big 7 times big 1, big 7. Good. And then x times x. What is that? Do you remember? It's x squared. Remember, quick review, we'll write it over here to the side. A to the m times a to the n. That's where you add the exponents together, okay? So we'll even write its converse out. A to the m divided by a to the n. This is where you subtract the exponents. We're going to have to use those skills today. So you might be like, yeah, what exponents? I don't see any. So remember, if there's nothing showing there, there were little ones. Those are the two ones that added together to make that squared. Oh, yeah, remember? Good job. All right, a positive times a positive is a positive. Big 7 times big 4. Come on, brain, you can do it. Good, 28. And then this is an x, and I don't have another x over here, so let's just tack him on to the end, and you're good. Is this written in order from the highest exponent to the lowest? It sure is. That's a squared, and that's a 1. Good job. So real quick, just to make sure that you're still awake and your brain is just remembering the distribution rules, I want you to pause the video. I want you to try number 2 and number 3. On number 3, make sure that after you distribute, you also combine like terms. Go! Let's talk about number 4 together. So here we're going to be running the machine backwards. We're going to factor. And so when I factor, I'm asking, what do all of my terms have in common, both by constant and by exponent? So let's write down a couple of questions to have us focused well on what we're doing. Is there a constant that each term is divisible by? So that's one question. The second question is, does each term have a same variable? I didn't ask about exponents, I asked about variables. So we're going to draw this out and we're going to see how to look at it so that we can get some good skills, okay? So let's look at number 4. In problem number 4, the first question is there a constant that each term is divisible by? This has a 1 in front, and the second term has an 8 in front. Are 1 and 8 both divisible by something the same, bigger than a 1? No. So the first question is kind of a moot point. It doesn't do anything for me. The second question, do each of my two terms have a same variable? Yeah, they do. They both have a t for turtle. So you have to be very careful in this problem to make sure that your plus sign and your t look completely different. So I always make my letter t's, when I am writing those out as a variable, have a little scripted tail on the end. And that way I can tell. So t squared is really t times t, right? Plus 8t. So I want to take what they both have in common, what both terms have in common. This has 2 t's, but that only has 1. And I'm taking the exact same from both of them. So since I can only take 1 t from the second term, then I'm just going to take 1 t from the first term. That is what they have in common. So when I factor this, I say, what did they have in common? That letter t. That is what they had in common. And then I say, okay, what did they not have in common? Well, the first term still has another t, and the second term had an 8. Oh, there it is. That is my factored form. Okay? So a check would be to distribute this t back through the parentheses, through the quantity, and see if you get back your original problem. If you do, then you probably did it right. Nice job. Let's look at number 7 together and see how it works. All right. In number 7, we have 17xy to the 4th plus 51x squared y cubed. All right, 17 and 51, that is awfully suspicious. Now, I don't work with a lot of 17s. It's just not a common number to mess with unless you are 17. And then you're like, hey, I'm 17. Everything should be 17. But that's fine. So let's just check. Let's see if 51 and 17 are related. So to do that, let's go put this into your calculator and just say 51 divided by 17. Check it out. I got a 3. So yeah, they are very related. Let's go use it. So I've got a 17. Let's draw this out. Let's expand it. I have an x and I have 1, 2, 3, 4 y's. Now this 51 we said really is 17 times 3. We found that in the calculator. I have a couple of x's and I have 3 y's. And I wrote it expanded like this so that you could see why I'm doing what I'm doing. And then we'll do it the rule faster way, because you don't want to have to expand it out, but the expansions always work to help you. So what do they both have in common? They definitely both have a 17. They are both divisible by 17. So that is the constant that they each have in common. Variables that are the same. Do they both have x's? They sure do. Do they both have the same number of x's? This has 1 x. That has 2 x's. So I only take exactly what they have in common, which is just 1 x. So that one stays. All right. Now we both have y's. This has 1, 2, 3, 4 y's, and this has 1, 2, 3 y's. So how many y's could I take so that I take the same from each? Good, the 3 y's. So I end up leaving one of these behind. So that's y cubed. Because 1, 2, 3 of them, that's y cubed. Great, so this is what my two terms had in common. What don't they have in common? Parentheses. In my first term, what remains there? Good, a y. Plus, what remains from my second term? A 3 and an x. Great. This is it. That's your final answer. Let's look at how to approach that from just the rule standpoint. So from the rule standpoint, I'm going to rewrite this just so we can see it a little bit more clearly, but it's the exact same problem. 17x y to the 4th plus 51 x squared y cubed. My original problem. So I wouldn't usually go to the trouble of expanding all of this out. I don't know if I would even say, oh, by the way, 51 is really 17 times 3. I would check it in my calculator if I didn't already know, and I would be like, oh, cool, it really is. I'm taking that. But then I would say, okay, this has an x, and this is an x squared. So I'm taking the smaller one of those, and whatever the exponent is, I subtract it. So I pull an x, I'm keeping that, and I know this is going to become an x to the first, because 2 minus 1 is 1. I can already go ahead and put in this. 51 divided by 17 is 3. Okay. And then I would say, all right, I've used my 17. I've used my x's. I have a y to the 4th. I have a y cubed. This one is smaller. So I'm taking all of it, y cubed. And that 3 I am subtracting from that exponent on the first term. So 4 minus 3 is 1. I just have y to the 1. So there it is. It's the exact same answer. It's done a little bit faster, but that's provided you remember the rules. If you don't remember the rules, expanding always works. It always works. It just takes a little more space, a little bit more time. Okay? So I want you to do number 5, number 6, and number 8. Pause the video, 5, 6, and 8. And if you're stuck, come and talk to me, and then we'll finish up on the back. All right, we're going to do number 10. I'm going to let you do number 9 on your own after we do number 10. So let's do number 10 together. A rectangle has a length of 6x cubed y squared minus 1. Ooh, that's big. Let's go ahead and box that up. I just have a feeling that we are going to need that. And then it also has a width of 3xy plus 2. Yeah, I got a feeling we're going to need that also. So we are reminded that the perimeter for a rectangle has a formula of the perimeter is equal to 2 lengths plus 2 widths, where L is the length and W is the width. What is the perimeter of this rectangle? And then simplify your answer. This simplify your answer means combine like terms. I'll write that down. Okay, let's write down your original formula for the problem. The perimeter is equal to 2 times the length plus 2 times the width. And I always make my L for lengths look like a cursive scripted L, and that way you're not like, is that a 21? What is that? No, it's an L. Okay, so now we're going to take our length. We know that our length is equal to 6x cubed y squared minus 1. They told us that in the problem. And we're going to take all of this and put it in for that L right there. We know that our width is 3xy plus 2. We're going to take all of this and put it in for that W right there. So let's rewrite. Here again, this is where parentheses are our friends. So I have 2 times the length. What was the length? 6x cubed y squared minus 1. Close parentheses. Plus 2 times the width. What is the width? 3xy plus 2. Great. So we've done it. We have found the perimeter. It's not cute, but we've done it. Let's go simplify our answer and combine like terms. But in order to combine like terms, I have to distribute my 2's through the parentheses and then go combine. So big 2 times big 6, 12. Do I have to multiply an x or a y? Nope, just bring him down. A positive times a negative, it's a negative. 2 times 1, 2. Great. A positive times a positive, it's positive. Big 2 times big 3, 6. Do I have any variables to multiply in? Nope, so just bring them down. A positive times a positive, it's positive. Big 2 times big 2, big 4. Excellent. All right, let's combine like terms. This has an x and a y. This has an x and a y. Can I combine the 12 and the 6 to make 18? No. Why not? Good. This has exponents, and this doesn't. It's the same letters, yes, but the exponents do not match. They must be exactly the same. So I cannot combine them. I'm going to write them. Yeah, 12x cubed y squared plus 6xy. But I cannot make that 18. No. What can I combine? A constant of a 2 and a constant of a 4. That's what I can combine. So negative 2 plus 4 is, you're right, positive 2. And that is the perimeter of that rectangle. Done. Simplified, combined like terms, it's good to go. All right, your turn. Go do number 9. And when you finish, or if you get stuck, come and talk to me.